Okay, so we'll start notes. So 113, 21. So we're going to do a little bit of review of 5 steps to solve equations. This is the first part. The second part will be on the radicals. Now, this is to solve probably like 99% of any of the equations that you'll be given to solve. There's a few exceptions, but like I said, this handle most of them. So step 1, we're going to distribute the parentheses. Now, sometimes an equation won't have parentheses, and we would just jump to step 2 and go from there. If you use this like a guide or a roadmap, it just makes things very simple, or more simple anyway. Combine like terms. And that's important that you realize it's on the same side of the equals. Some of my students prefer to make the line down the center and then use it from there. Step 3, we're going to move the variables. Most of the time they're x's. Sometimes they're not. To one side of the equals. And if variables are only on one side, then you're going to go to step 4. And we're going to move the numbers, also called constants, to the opposite side of the equals. That's of the variables. Okay. Some of you are still writing. When you get down to step 4, you should have something that has variables on one side and numbers on the other, kind of like a 5x equals 10. That's what it would look like when you get down to here. How would we solve a 5x equals 10? What would we do?
Divided by 5.
Mm-hmm. So we're going to always divide by the number next to x. So that's our step 5. Divide by the number next to x, or your variable. So some of our exceptions come in, like if this was an x divided by 5 over here, then we would do the opposite and we would multiply both sides by 5. But they're very rare. Okay, and then we'll do one together also. Oh, we're only missing 2 people. Okay, so let's do assignment number 1, number 2. So the second problem on that first assignment, we'll do it together. So negative 87 is equal to 3 times the quantity 3b plus 1 plus 6b. Okay, so using the 5 steps as a roadmap, first step says to distribute. That means we're going to take the outside number or term and multiply it by both of the inside terms. So negative 87 is equal to 9b plus 3. Do I need to multiply the 3 times the 6b? Yes or no?
Yes.
Okay. Well, the 6B is not inside the parentheses. It's kind of a trick question. So if it's not inside the parentheses, that would be a no. Okay, so it only gets done to the, it only gets done to the things that are inside the parentheses and nothing else. So we're just going to actually bring it down. And comes along for the ride. Okay. Step 2 says to combine the like terms on the same side of the equals. So if you want to draw the line, you don't have to, but just visually it's easier. Over here, we only have a negative 87, but over here, what are the two terms that I can combine?
9b plus 6b.
The 90 and the 6b. We're going to do the operation symbol that it says because when it's on the same side, we combine, we don't do opposite. So we've got negative 87 still over here, 15b plus 3. Okay. So now step 3 says move the variables to one side. Well, they're already only on one side. So that means that we need to move the 3 to the other side. And how do we move the plus 3 to the other side?
R.
Okay, well, it's a plus 3, so we have to,
Sorry.
good. We have to subtract 3. Because what I tell my algebra students is when you have to cross the line, you change the sign. Cross the line, you change the sign. So negative 90 is equal to 15b.
Dividing.
Yep, divide, good. Step 5, let's cancel. We get negative 6 equals b. And you're done. So I'm going to ask you a minute to think about maybe perhaps when you were starting to learn these or someone else, what would be a common mistake that someone might make when they're learning how to do these, or if they're not being careful?
I think the subtracting and adding, I think that could get tricky sometimes. I know it gets difficult with me. I kind of forget too sometimes of like which one it's going to be.
Right. Good. Yep. Yeah. So especially if you know it's true for you, just take your time whenever you have like negative and negative, or if you have to, add them here and subtract it there. Yes, those are very tricky. What else? Anything else that might be a road trap? Yeah. Okay, good. And somebody in the chat put distribute. And so distributing can be tricky because if they distribute to the 3B, maybe they forget to distribute to the 1, or maybe they also distributed to the 6B. Okay. So that's definitely a tricky part. Okay. So these are things just to keep in mind when you're doing problems, to be careful. Okay. And especially if there's a negative outside the parentheses, distributing the negative 3 gets even more tricky. Okay. Good. I hope that helped a little bit. Yes, there are, when you have come down to this second line, there's a couple different ways that you can go. But if you are consistent with the steps, it just makes things easier. Okay. So now let's talk about simplifying radicals. Now, we did do this last semester. I'm just going to touch on it a little bit. So if we were to simplify the square root of 90. But the good thing about this semester is if you choose to stay, whether or not, because if you didn't do very well last semester, my juniors and seniors generally have enough credits that they could take an elective if they choose to. But if you're willing to make a few changes and work habits and, working with me and being here, then you could still easily pass the second semester because it doesn't have as much to do with the first half as it does just what we learn once we move on. Okay. So simplifying this, we want to break it down. What goes into 90?
Nine.
Okay, 9. So 9 and 10. Good. 2 times 45, 3 times 30. There's like 6 different ways or so. And then we could continue to break it down. So 9 becomes 3 times 3. 10 becomes 2 times 5. I am totally fine with you saying right here that the square root of 9 is 3. However, many of my students like to see it completely broken down so that they can circle their pairs. So we can circle our pair of 3s. And for every 2, I get to bring 1 outside. So bring that one outside. The one that gets to go outside is a pair, and the leftovers have to stay inside. So I'll multiply them back together, and we have 3 root 10. Okay. Hopefully this rings a bell. Sounds familiar from last time. Go ahead and do root 54. And let's see if we all get the same answer. I'll give you just a minute to do that. So what did we get for that? Okay. A couple of people putting it in the chat box. Good. Anybody can say it out loud? Okay. Well, this is where you need to know if you can do it without me. So what goes into 54? Like everybody went to sleep on me here. Okay, come on, guys. So 9 times 6. A couple people put it in the chat box. And then we can break this one down to 3 times 3 and this one to 3 times 2. So I have my pair of 3s. And so I can bring out a 3. Okay. Then bring out a 3. And then my leftovers would be root 6. So 3 root 6 would be your answer. Good. Okay, so now we're going to switch gears a little bit, and instead of simplifying like that, we're going to divide. We're actually just going to rationalize. Anybody still writing? Okay. And that's it. So this is what we call rationalizing the denominator. And many of you may have seen this, maybe not, but we'll touch on it. because we may be doing some of this when we hit the triangles. So rationalizing the denominator. So long words, denominator, meaning the bottom of our fraction. Rationalizing is like simplifying our fraction, because we can't leave things like 2/4. This 2/4 can be reduced, and it's the same idea. We can't leave it in an inappropriate form. So rationalizing just means getting rid of the square root in the denominator or below. So here's a fraction, and not many people really know what this is. I mean, like 1/2, that's a half. And we can visually, mentally picture what a half looks like. I can't picture this. You know, I'd have to do a whole lot of mental work to try to even picture this. And it's okay, but I can't leave a √7 in the denominator. That's like against the math rules. But I know that if I have 2 of the same radical, it makes a pair and I can get a whole. We'll talk about that in a second. But remember, if I do something to the bottom, what else do I have to do?
Same thing to the top.
Yep, same thing to the top. And the reason is because something over itself is a 1, and I can multiply anything by a 1 and not change its value. And I can change how it looks, I just can't change its value. So if you'll remember that we can take out, anytime we have 2 of them, we get a whole. It's kind of like a half and a half makes a whole. That's the same idea. Now think about these. This is very, very important. The 5 is an outside number. The 7 is an inside the root number. They do not mix. I cannot say 5 times 7 and get a 35 because they're 2 different types of numbers. This is, the root is kind of like an X in that it just sits next to each other. So you'd have 5√7 over 7. So here's what we need to remember. So we'll write it down. We need 2 of the same root to get a whole. And if you don't believe me, you can multiply, you know, we multiply outside numbers with outside numbers and inside numbers with inside numbers. If you multiply √7 times √7, you get 49, and the square root of 49 is 7. We just don't want to have to do that extra mental step because it's more work than we need to do. Okay. So if I've got √6 times √6, what does that give me?
6.
6, good. How about √11 times √11? What does that give me?
11.
11. Yep. So that's why we need 2 of them to make a whole. Okay. Let's practice another one. 8 over √3. Actually, make it 18. Make it 18. I have a reason for that. Okay. Do I multiply by 18 or by √3?
√3.
√3. Good. Always multiply by the denominator, the root in the denominator. Now, if that were a √27 or √30, we'd want to simplify the radical first and then multiply by whatever's left in the root. Okay, but we're not going to get that complicated right now. This is just the skill we need to be able to do our triangles. Okay. So what does that give me on the bottom?
3.
3. And on the top, these don't mix, so I'm just going to write 18 √3 But if you notice, now I've got outside numbers, an 18 and a 3. Does 18 divide evenly by 3?
Yes.
It does. So we'd want to simplify and call it 6 root 3. Then we'd be done. Okay. If it didn't, and it was just an 8 like I had it originally, we would just leave it as 8 root 3 over 3, like we did the first one. Okay. And last, root 7 over root 5. Do I multiply by a root 7 or a root 5?
Root 5.
Root 5. Always the one in the denominator. Okay. So we know that on the bottom, we're going to get a what?
5.
A 5. Okay. So now the important part on top is to say, do I have inside numbers and outside numbers? Or do I have 2 inside numbers? Do I have 2 outside numbers? So what would I get on top? Some of you are a little unsure. Some people are putting it in the chat box because they're not sure. So if I had, I'm just going to do it over here, 7 times 5, we know that that's 35. If I had a 7 root 5, I couldn't multiply those because one's an outside number, one's an inside number. But if I have root 7 times root 5, because they're both inside, I can actually multiply them both inside. You get root 35. So inside numbers with inside numbers, outside numbers with outside numbers. Now think about this question before you answer. Can I divide the 35 and 5 and get 7?
Yes.
Does anybody
No,
disagree?
because 5 is an outside number, 35 is an inside number.
Okay, because that was kind of a trick question. One is the 35 is an inside number and the 5 is an outside number. So you cannot divide them as they are. Okay. The reason we divided the 18 and the 3 here was because these were both outside numbers. Okay. That's why it allowed us to get the 6. But the root 3 didn't get touched. Okay. It was still an outside number. It was off limits. I'm sorry, inside number. It was off limits. Okay. So this would be our final answer. Okay, let's see. Good comments in the chat box. I appreciate that. So is there anything that I can clarify? I know that's some of you haven't seen that before. If you need to, we can back it off. You can take a picture if you need to. There's only a few on the assignment sheet. There's like 4. So simplifying and rationalizing. Anytime you have a denominator, you need to rationalize it. I would encourage you to use the extra 10 minutes that we have to start on the assignment. I'd like you to try and do what you can tonight so we have a little bit more time tomorrow to start on the triangles. I am, however, going to, if you need to log off, I'm going to let you go 10 minutes early if you need to. Otherwise, you can stay around and talk with me, ask questions, and go from there. And we'll meet again on Friday.